So I wanted to get things going, and thank you all for listening to this awesome keynote and for giving our sponsors a little bit of a window in there. And I'm excited to be able to host this in virtual. It's my first conference helping out, and Paul's done an amazing job at getting everything to go together. So I wanted to first introduce Steve Flanders. If you're not in the speaker-Flanders chat, drop in there. Hey, Steve. And then we've got 3 other folks helping out with Q&A in Slack as well. There is, well, I'll let Steve introduce the GoToMeeting format, and just sort of say that Steve's been in the observability and OpenTelemetry space for a lot longer than I have, way back from OpenCensus for the CNCF project before it was, revisioned into OpenTelemetry, and that I know he was involved in creating the foundations of a lot of that code base, which has now become something much bigger than either of us. So with that, I'll let you introduce yourself as well. Thank you so much, Steve.
Great, thanks. Thanks for having me. So let me go ahead and share my screen here. So I'm going to start just with a few slides just to provide some context here, but the goal is really to be a hands-on workshop where you can get some actual experience leveraging OpenTelemetry for your application in your environment, no matter where you are on your journey, whether you have some amount of instrumentation today, maybe based on open source things, whether that's Zipkin, Jaeger, or something else, maybe you have custom instrumentation, or maybe you have no instrumentation at all. And what this project actually provides and makes it easier for you to actually get rich telemetry insights from the applications that you're running in your environments today. And with that, so the slides are going to work here. Let me just introduce myself real quick. My name is Steve Flanders. I'm a director of engineering at Splunk. I was previously at a startup called Omnition. We were in the observability space and worked very closely with Google and Microsoft on the OpenCensus project. We actually helped build the OpenCensus collector, which is now the OpenTelemetry collector, which is basically a vendor-agnostic way to take the telemetry data from OpenTelemetry or from other open source instrumentation libraries like Jaeger and Zipkin and send them to the backend or backends of your choice. Prior to working in more of the distributed tracing space, I was at VMware working on the log analytics space for both their on-prem product Log Insight and SaaS product Log Intelligence. I provided some links to some ways you can check up on some of the work that I'm doing. Okay, so as I mentioned, I don't want to spend a lot of time on slides, but I do want to provide at least a little bit of high-level context here to kind of set the stage of what we're going to do. And then the idea is to go through a variety of different workshops, and they're all kind of configured in a way where you can pick and choose what you care about. So if you don't want to do all of them, that's fine. If you only care about certain languages, or if you want to do the whole thing, it should be pretty readily available. Knowing that this is kind of a virtual setup, it can be a little bit harder to collaborate and to help people if they get stuck along the way. But we're going to try a few things here that I'll show in a few slides when we get to the workshop section that'll hopefully make it a little bit easier today. Now, I don't want to spend a lot of time introducing OpenTelemetry. Hopefully you know a little bit about the project. I'll stay pretty high level. There's going to be a lot of people today at this conference talking about the project, its current status, where it came from, how you can get started, all of that. So just to kind of set a little bit of the stage here, if you've heard of observability, you probably heard of the 3 pillars of observability being traces, metrics, and logs, which are basically different signals of telemetry data that you can collect. But what you may or may not realize is that for each of these, as the slide here calls them, verticals, there are actually many different layers that are also involved. Everything from the instrumentation APIs that you leverage to actually get the telemetry data out, the data infrastructure, which can be, for example, the collector or agent mechanism of where you're sending this data, all the different interop formats. So, for example, the little bit newer W3C trace context correlation, other header propagation formats as well. All of these are super relevant for things that you'll need to really get started with cloud native telemetry. And all of these different aspects are areas that OpenTelemetry is looking to tackle. To be fair, OpenTelemetry hasn't tackled all of it yet. So the initial focus was really on tracing, and that's where we're going to spend the bulk of the day today, is talking about the tracing aspects. Metrics is also moving along very, very quickly, and logging just recently got started. So there's actually some conversation about a logging SIG, and you can, of course, get involved with these pretty easily through the community channel. All the different SIG meetings and links on how to participate are readily available, and always looking for additional contributors. So basically, OpenTelemetry is looking to tackle all of these aspects long term. And really, the best way to think about this is probably everything that you're deploying in your environment, everything from the instrumentation to the data collection aspects, but it doesn't provide a backend for you. So that's kind of left open. And the idea here is really to provide choice. So the goal is not to lock you into some solution. The goal is to make it easier, like which instrumentation library should you install? At the end state goal, ideally, OpenTelemetry is available out of the box. And so just by leveraging that, it doesn't matter the backend you're sending it to, you can take advantage of that telemetry data pretty easily. Okay, so in regards to the components, there's really two primary components that we're going to be dealing with today, and they're the kind of the bulk of the project as it stands today. The first is the notion of this collector. As I mentioned, it's a vendor agnostic way to basically receive, but it can also process the data before it sends it, and then export that data to one or more different backends. It's really the default way to collect OpenTelemetry instrumented application data. So for example, if you take a dependency on the OTel client libraries, as the product goes from beta to GA, what you'll see is that it'll natively support exporting in OpenTelemetry format, which if you happen to deploy a local collector, automatically that data will be collected, processed, and sent to the backend that you configured. So it really makes it seamless. The idea here is that adding client library information is typically the hardest part because it requires modifying your code, going ahead and testing that for performance, pushing it through your CI/CD pipelines and getting comfortable with its state. You probably don't want to touch it all that often. I mean, if you need additional telemetry data, you'll of course make modifications, and everything regarding the client libraries is going to be language specific. So just because you change it for one language in your environment, if you're in a polyglot, you're going to have to go ahead and modify that in others as well. The agent collector kind of provides a layer of abstraction for you. It can offload some of the responsibilities that would otherwise need to be handled in these client libraries, and makes it a little bit easier to kind of control the data that you're flowing through your environments. Now, on the client library side, again, vendor agnostic way to instrument. The goal is to become basically the standard. Everything will be packaged by default, that hopefully that will include this in the future, which means you don't really have to think about it. It should just be there by default. Right now, these client libraries support both traces and metrics, and there is some amount of automatic trace instrumentation available, specifically for Java right now, but the Python SIG is getting started as well, and you're going to see additional support in other languages. Basically what this means is for most of the client libraries today, you need to go ahead and make manual changes to your code in order to instrument it. That's actually what we're going to do in the workshop today. But long term, the goal is to make this easier and basically provide automatic instrumentation, basically like bytecode manipulation. Whereas you don't modify your code, you either take a dependency on something, or like in Java, you use the Java agent flag, and you can go ahead and hook into your existing code and get some amount of telemetry data out for free without having to go ahead and make manual code changes. Now, as you probably know, the OpenTelemetry project recently announced that it's in beta, which is super exciting, and many different parts of the project have reached this beta status. I've listed them here. So basically there are 5 client libraries, including Java, which is the only one right now that has auto instrumentation as well. The JavaScript one, I didn't put it here, but that includes both Node and browser-based instrumentation, which is super cool. And the collector, the name might be a little confusing, but the collector also runs as an agent. So it's basically the way of performing data collection for the instrumentation that you have. All right, so I want to walk through very quickly kind of a reference architecture of how this might look as you roll it out in your environment. So basically, what I have here is an example of a host, whether this is bare metal, Kubernetes, whatever, and you could have one or more different applications running on that host. And basically, your goal is going to be to instrument that application and to have that data be sent to one or possibly multiple backends, depending on what your business requirements are. So typically how this gets phased out is initially you would go ahead and deploy the OpenTelemetry collector as an agent on each of your hosts. So for example, if you're in Kubernetes, this could be a daemon set. It is a binary, so you could run it as a sidecar within your application. You can run it with your application. There's a variety of different deployment models. Really, the goal is to provide flexibility and choice for you. And then that collector would be configured to send to one or more different backends through a YAML configuration file. So here I'm showing an example of where you might send all of your trace and metric data to one backend and maybe a subset of your metric data to a different backend. Really, it's quite kind of flexible depending on what your needs are. Now, deploying the collector first, as I mentioned, makes things a little bit easier because the idea is as you add this instrumentation, if the collector is there, it'll automatically start picking up that data. So the collector can also be configured to go ahead and gather host-based metrics. So anything on the host, for example, Prometheus or Collectee or whatever else is useful, you can go ahead and get that information, have the collector pick that up. And then the next step would be going ahead and adding the OpenTelemetry client library to your application and then configuring that to send to the collector. So again, the host here would be a metrics-based collection, and then from the OTel library, you can collect both traces and metrics depending on which code changes you make to your application. So this is one way to deploy it. Another potential option would be you can actually have the OpenTelemetry collector be a standalone service separate from your application that runs independently, and you can scale it out as need be. There are some use cases for this. For example, if you're interested in doing something like tail-based sampling, then you need to go ahead and aggregate that trace data ahead of time, so the collector can be used for that. It can also be used to reduce the number of egress points you have from a security perspective. So maybe you don't want to add the API token because you're sending to like a SaaS backend to all of your agents on all of your hosts, and you don't want all those agents on all of your hosts to have access to the intranet. So that could be a compelling reason why you go ahead and deploy the collector service, which basically fronts any internet traffic. So in this model, basically the collector runs the standalone service, and in this case, the collector running as an agent would send to that service, and then the service would send to the backend or backends of your choice. Now, in this model, everything else is the same. So you have the OpenTelemetry client library sending to the local agent. You can still collect metrics, and it's very flexible. So you can change this. You can actually nest and have different collectors. You can have multiple different tiers of collectors, for example, talking to each other if that is necessary for your environment. Okay, so as I mentioned, very high level basic information about what OpenTelemetry is, some of the different components that are involved. We're actually going to be playing with many of them here today. The rest of this time is really spent on being a little bit more hands-on and to get some experience and hopefully encourage you to help get involved in the project, to start leveraging in your environment, and to really see the value that it provides when you get everything hooked up. So I'll start by providing some high-level information. These are some tips and tricks that I've found to be useful doing some of these more virtual events because they are a little bit different. First off, there is a Slack channel. It's called Speaker-Flanders. In there, I posted the above link, which has basically all the materials that we'll be leveraging today. So if you have a question, in general, I would ask you to go ahead and put that in Slack. I actually have other folks that are joining me today that will be helping answer these questions. And I'd also encourage you to leverage threaded conversations whenever possible. Otherwise, things can get very busy very quickly and your message might get lost. If you feel like your message doesn't get responded to, go ahead and like post an update about it, or you can even tag me in directly to your threaded conversation, and I will definitely respond throughout this workshop. Now, the only question you really need to answer, there is no prerequisite information unless you, prerequisite steps unless you want there to be. So there are basically three options available to do this workshop that we have for you today. There's Glitch, which is a free public way of basically hosting and running this code. Super cool if you've never used it before. That's where we're going to start today. Basically, you can collaborate pretty easily. You can share the information publicly. You can have other people kind of join your project. You can edit together. Super cool and collaborative. The things worth noting is that Glitch only exposes a single public port today, and from what I can tell at least, it doesn't appear to support gRPC or HTTP2 traffic. So that does limit some of the things we can do, for example, like sending through the collector. So we've made some modifications to this workshop. We're gonna, for example, leverage Zipkin instead of the OpenTelemetry protocol, just so that we can work around that and make it work within the Glitch environment. Now, you don't have to use Glitch. You can actually do this locally as well. The workshop is pretty flexible. None of the steps that we're doing have any real hard dependencies. So if you're comfortable running this locally, there are package managers for each of the languages we're going to use, so it won't modify your system in any undesired way, but it would require you to do some local installation of things depending on the languages and libraries you're going to be leveraging. You can also do this exact same thing in Docker. So for example, if you just want to spin up an Ubuntu Docker container or any real Linux container and go ahead and add the GitHub repo in, you should be able to get started pretty easily. Though with Docker, if you're not totally comfortable with it, the networking aspects can be a little bit tricky, something to be aware of. Now for this workshop, we actually have 4 different languages for you. So basically we have a Go application that talks to a Python application, the Python application talks to a Node application, and the Node application talks to a Java application. So really this provides an opportunity to touch 4 of the 5 languages that have made it to beta today. And again, the focus is going to be on the tracing aspects. There is, for each of these repositories, there's actually a PR up that has the metric support, which we'll go ahead and merge in, but we didn't want to provide too much confusion here. So we're going to start with the tracing aspects. And then the final thing here is just please be patient. I know it can be sometimes a little frustrating or a little hard to do this in a virtual setting, perhaps I'm going too fast. Go ahead and provide that as feedback in the Slack channel, and I can definitely try to slow down. Or maybe you have an issue using Glitch, you never used it before. So we're going to try to be responsive as possible in the Slack channel. So definitely ask your questions there, but do give us a little bit of time so we can hopefully respond and get you the support that you need. Okay, so as I mentioned, we have in this workshop, we have 4 different languages we'll be playing with, as well as the OpenTelemetry collector running as a service, not as an agent in this particular environment. And basically the chain of events here is we provide you with 4 applications that are uninstrumented in 4 different languages. So this is kind of traditional microservices polyglot type environments. They both have basically a RESTful endpoint, so web traffic is being passed between these nodes, and you get some basic information in the UI about whether the communication paths are working or not. So what we're going to end up doing is going ahead and configuring the collector first. So the collector in the environment is actually configured for metrics only. We're going to add some tracing support for it. This gives you a little bit of exposure to how to actually configure the collector. Relatively straightforward. It's a YAML-based configuration file, but you do need to understand the syntax and kind of how the architecture of the collector works. Then we'll go language by language. So we'll go into Go, we'll go ahead and instrument it. And the idea here is that everyone should be able to do that on their own. If, for example, you don't care about Go, you don't want to do Go, that's fine. You can actually skip any of these steps if you want to. It is ideal if you follow the chain of events, but you can even modify the code to like have Python called Java, for example, or have Go called Node. It's pretty flexible. The idea here wasn't to make it too complicated. So you'll go ahead and configure Go, you'll confirm that that's working properly, then you'll go ahead and configure Python, you'll confirm that that's working properly, Node, and then finally Java. Now, as I mentioned, given that this workshop is going to be run in Glitch primarily, unless you're running it locally, and there are some limitations here on what we can send in terms of opening of ports and HTTP2 traffic, we're going to be leveraging the Zipkin exporter for tracing. And of these 4 languages, Java does not have that Zipkin exporter today. So we're actually going to leverage just console logging in the Java case, so you can actually see what the payload would actually look like, but it won't actually send the collector because the Zipkin support's not there. It does support Jaeger, but some of the other languages don't support Jaeger, and again, we can only expose 1 port. If you're running this locally, if you're running this on Docker, you don't have that limitation, so then you can configure the whole thing end-to-end pretty easily, and all the code examples actually show you how to enable like native OpenTelemetry exporting, so it's pretty easy to swap out the Zipkin exporter if you don't want to use that as well. Okay, so first up, for the first step here, what I'm going to end up doing first is I'll walk you through a little bit of Glitch in case you haven't used it before, just kind of navigate through the UI. But the goal here is we'll go ahead and go into Glitch and look at the collector environment that stood up. There's a GitHub repo for this as well. Basically how Glitch works is you can go ahead and import a GitHub repo. That's what we've done here. and that glitch collector is configured to run by default, but the default configuration only provides metric collection. So what we've actually done is that collector is scraping its own metrics, its own Prometheus metrics, and it's logging that out. So that just confirms that the collector is up and running. Your first task here is going to be to go ahead and edit the configuration of the collector so that it can accept trace data. So what we've done is we provided readmes in each of these repositories with kind of steps to walk through, and then through Glitch or through your local environment, you can go ahead and check the logging information to make sure things are working properly. So with that, let me switch into Glitch in case you haven't used it before. So for example, here we are in the collector workshop. So if you open up the collector workshop, if you just go to glitch.com, actually, let's take a step back so I can show you everything. And I go to meetings in the way. There we go. So if you just go to glitch.com and you search for OTel-workshop, you should see a variety of different workshops that are available. We're going to start with the collector one. So one of these should say SignalFX OTel Workshop Collector. You go ahead and click that and edit or show the project. Given that I'm an admin, I can edit it. This should go ahead and launch the project. Do note it does take a little bit of time. In fact, since I've been presenting here, I'll just go ahead and refresh these. They do go to sleep after, I believe it's 5 minutes of time. They do come up relatively quickly though, so usually you don't have to wait very long to get them going. So here's the collector one. As you can see, I have the README open. There's a bunch of different files here, very similar to the structure that you have in your GitHub repository. Once you log in, things worth noting, you can click around and you can actually just see the files pretty easily. In addition to that, you have different tools that are available to you. So for example, I mentioned that we're running the collector with metric collection by default. So if you click on logs, you'll actually see that the collector is running and has been running here for a little bit of time. It does show you all the log information. These are info messages. They are red, but that doesn't mean that there's an issue here. And then as I mentioned, this thing is currently configured to collect its own metrics and log those to the console here. So you can see that it is scraping its own metrics as it runs. So basically what you would do is to get started, you can click the project link at the top and you can select Remix Project. So this basically creates a copy of it and will give it a new name, and it's just a dynamically generated name. You can modify that name however you see fit. But if you remix the project, then you can go ahead and make edits to the copy that you have made. Super cool. And so that allows you to go ahead and modify and test out this workshop yourself. So I'll go ahead and do that right now so we can take a quick look at this. Here we go. So you can see it created a new name for me. So now I'm called Woozy Achieve Diagnostic, and it'll spin up that project. It does need to go ahead and spin this up in the background. It does take a little bit of time, but it's pretty fast. And now I can go ahead and make changes to this. So it'll end up in the same state. You can see it started up. Eventually here, it'll start logging out the metric collection. And then in addition to the logs, there also is a terminal. Both you can run the terminal locally here, and you can see the entire directory structure. So everything inside of the app directory. So here you can see the exact same files that you see on the left-hand side. You can go ahead and make changes to the command line, or you can make changes to the file directly in the UI. Either works, and you can kind of test things out pretty easily. Worth noting, you probably won't run into this, but the collector is probably the only one that's kind of close on disk space. You only get 200 megabytes of disk space, so don't put anything big in here. Otherwise, you can hang the project that you remixed, which isn't any fun at all. So basically what we'll do here is hopefully the readmes are pretty self-explanatory. They kind of provide you some basic information of what we're going to do. So what I'm going to encourage you to try is to go ahead and remix this collector one and go through this README. It shouldn't be that long, shouldn't take too much time, and go ahead and add the configuration aspects. If you do that, and as you make those changes to the files, you'll actually see the service reconfigure itself dynamically, and you'll see new log messages come out. So if you make a typo or a mistake, it should be pretty intuitive as to what's happening. So for example, let's go in here and let's say I configure Jaeger. You'll see that now it reconfigured, and in here I should see that the Jaeger receiver has been added. But if I make a typo and I put it in the wrong place, then it should go ahead and generate, oh, I'm actually not using this in the pipeline, so it won't show it. But if I do a configuration issue, like, I'll get rid of logging, then it should go ahead and throw an error for me and say, hey, your configuration is not valid. You should go ahead and make changes. And maybe we're in the wrong file. I am in the wrong file, that's why. Apologies. I didn't check my file name. There you go. So now I have a configuration syntax error in here. It should be pretty intuitive if you have the logs open as to what's going on. You can go ahead and then fix that configuration. And again, it will restart and you'll see that you have info messages. So I think that's a quick introduction. Hopefully that provides some context as to how to use Glitch. Again, you can run this locally or on Docker. I'd encourage folks, hopefully people have been poking around a little bit, but let's give it about 5 minutes or so for you to try this workshop. Give me an opportunity to kind of check on the Slack messages real quick. And then what we'll do is we'll come back and we'll do this lab together real quick. And then we'll start working through the different client libraries so you can get exposure to them as well. So with that, I will pause for a few minutes and check for questions in the Slack channel. Good luck trying this out and do provide feedback. Thanks so much. Hey, just a quick note, folks. Someone just pointed out correctly that the make file actually has the wrong listing to the binary. So just heads up, you should be using the OTel collector contrib one. I think it doesn't have contrib by default. So just a heads up if you're running this locally with the make file, make sure you use the contrib one. Also worth noting that only the Linux binary is added here. If you're running this locally on Darwin or Windows, you can go ahead and get those packages from the contrib repo by building the binaries yourself. Again, unfortunately, there's a limit on the disk space on Glitch, 200 megabytes, so it's not possible to add all 3 binaries here. If you're interested in those binaries, let me know in Slack. I have them locally available. I can probably upload them pretty quickly if people don't want to build else. So we'll give it another, let's say 3 minutes here, and then we'll come back and try out the collector workshop together. All right, so let's come back. Hopefully you've been playing around a little bit with this. You might still be working through it, and that's okay. Just want to provide a little bit more information for you. Hopefully you've read through the README. It has some good pieces of information to be aware of. With Glitch, basically port 3000 is exposed internally, and that maps to port 443 on the internet, or even 8443 on the internet. So what we're actually doing in this lab is not just enabling tracing, but we're going to specifically enable the Zipkin receiver, and we're going to explicitly tell the Zipkin receiver that it should listen on port 3000. So that way we can actually hit it over the internet and send traffic from our instrumented apps, which will be coming up next. So that's the reason for that change. Also for the make file, I said OTel call contrib. It's OTel contrib call. You should see the file name here. So apologies for that. So as you go through this workshop, basically what you're going to do, what you'll notice as well is that we provide an example file for you. So there is one that is complete. Basically, this is some of the end state that you can end up with. And then you have your original file, which has metrics enabled by default. You can kind of see what a metrics pipeline looks like. You can see it has, for example, a Prometheus receiver enabled. You can see, for example, that it's just logging locally by default. So this is just a pretty basic configuration file, and your goal is to enable it to enable Zipkin receiving and to log that locally. So to go ahead and do that, what you would basically do is just go ahead and add a Zipkin receiver endpoint here. By default, the endpoints listen on local hosts by their native port. So Zipkin's native port is 9411. That's not going to work in this environment. So what we'll do is go ahead and add an endpoint where I'll have it listen on all interfaces, and I'll have it listen on port 3000 so that Glitch can do its magic of mapping that. So we now have exposed this basically to the internet. Now, just by configuring this receiver, it does not mean that it's being used by the collector. So the architecture here is kind of important. Basically, it's made up of different stages. You have a set of receivers. You can think of receivers as the way of getting data in, whether that is push or pull based is irrelevant. It supports both, but receivers are the way that you get data into the collector itself. Then you have a notion of processors. Processors are just a way of basically manipulating the data, modifying the data before you send it out. This includes kind of some offloading capabilities that would otherwise need to be handled in your instrumentation client libraries, things like batching, compression, retry, encryption logic. You can also do some more advanced things like adding or removing tags. Let's say you want to add some region-specific information or some data center-specific information that's trivial to do. Maybe you want to redact some PII information before it gets sent out because updating your client libraries to do that is going to take too long. You just want to do it quickly from the collector. That's all possible through the use of different processors. And then exporters, again, as kind of the name indicates here, is a way of getting data out, and you can send to multiple destinations if you want. There's also a notion of extensions. Extensions you can think of, primarily these are health-related things today, but they're things where you're not actually touching and manipulating the data that you're receiving and exporting. So there's a health check endpoint, there's pprof for performance testing of the collector, and then zpages, which is pretty cool. It actually shows you some telemetry about the data that's going through the pipeline and whether you're experiencing any issues along the way. Now, these different notions have to then be configured into basically pipelines. So at the bottom, you'll see this notion of a service. Service enables both extensions and pipelines. Extensions would be the extensions that you see above. So if I have an extension called health check, but I don't enable it underneath the extensions of the service, that means it's not turned on. So that means I will not be able to hit it. So basically you do your configuration outside of the service notion, and then you do your enabling within the service notation. And then finally you have pipelines. There's two different types of pipelines. Metrics, as you can see here, you have your receivers and your exporters, and then you can add traces as well. And those have receivers, processors, and exporters. Just for the sake of making this a little bit quicker, because I want to get to the other labs with you, I'll just go ahead and copy in the example here. But basically, what you would be tasked with doing is adding traces capability and then enabling one or more receivers. I only enabled Zipkin above, so the other ones are not applicable. Then processors, order operations does matter here. It's actually the order through which it goes through its different stages. So what this says right now is receive on Zipkin, go ahead and batch that data, do any attribute information. Here I'm actually adding a specific environment tag just for fun, and then go ahead and set up a queued retry logic so that if exporting fails, in this case to logging, you can go ahead and retry. Not really applicable for logging, but in general, batch and queued retry are recommended always because it can be unreliable to send to the destination you've configured, and because batching the data helps from a compression and data transport ability thing here. So we've gone ahead and done that. If you actually look through the info messages, in addition to seeing all the metric information, you should now see, like, for example, there's a trace pipeline that's been enabled. You can see the exporting for that trace pipeline. So you get some pretty good debug logs as to all the different things that were configured for the collector itself. And then again, it's still collecting its own logs. So the collector actually emits Prometheus metrics. We are scraping them locally, and we are just sending them out and logging, saying that we've received that data. Now that we have a Zipkin in here as well, we should be able to confirm whether or not the trace data can be received by this endpoint. Now, how the logging processor works, by default, it uses a log level similar to any logging tool out there. It's not very verbose initially. It just gives you some basic stats about the data that it's been collecting. But you can go ahead and modify this as well. For example, I can set the log level to debug, and then it'll be much more verbose as to the data that it is receiving. And you can actually see, like, for example, payload information and determine whether or not the messages you're receiving are what you expect. Other thing worth noting is that the name that you get of your project, this is actually an endpoint. So for example, this right here, I can now open up in a web browser, and I believe it's what, glitch.me, yes, and go to glitch.me, and this is an actual endpoint. So in this case, the collector is not exposing a website, so 404 not found, that's expected. But I can now send data to this endpoint, and I can confirm that things are working as I expect it to. So just for fun, for example, I'll bring up my terminal here, and I'll send a curl command. So I have a JSON file that contains a Zipkin payload. And what I'm going to do is I'm going to go post that to this endpoint, if I can type it in correctly here. just to kind of test it out. So this is basically saying, go ahead and post to this endpoint API v2 spans. That's basically the URL that's exposed by Zipkin. I'm sending this as a JSON payload, and I'm going to go ahead and send a JSON blob that I pulled from the Zipkin test data. And then that should post to the endpoint here. And then the data should go ahead and appear in the UI. What I should have seen is logging information actually come out here. I'm not sure why I didn't. Did I miss something? 3,000. Login receiver, Zipkin, queued retry. I would have expected that to have worked. So apologies, I had tested this before, but maybe I missed something quickly here. But this should have tested posting data to an endpoint. I can actually go back to my other environment that was working earlier as well, just to test that for you. Workshop edits. Cool. So I will just go ahead and enable it on this one and see if I can get it to work for you real quick. Trace. Okay. And all right, and let's just try that one more time. See if it works this time. There we go. And as you can see now, it actually logged the span information. So in addition to getting metric information, I can now see that it logged span information to that endpoint. If I go back and re-enable the debug logging that I mentioned before, log level debug, and I allow the collector to restart, and then I send that payload again, what you'll see is I can actually get the actual span information logged out here. So now it's being extremely verbose. It's telling me the trace ID, parent ID, all the different attributes that are available. So this can be very helpful for troubleshooting the payloads that you're sending in and making sure the data that you're expecting is the data that you're actually receiving and exporting out. Again, pretty easy to test out here. I can add this command into the README. I don't think it's there right now, but should be pretty straightforward to go ahead and test. We're going to be testing through the actual client libraries next, so you don't have to test with this Netflix.json file. I just thought it would be a good example for you to get more familiar with the collector. I'm just going to put this back real quick in case people are still remixing this project so they don't get impacted. There we go. Okay, so now we have basically a collector that is up and going. It now receives tracing data. We're basically ready to go ahead and instrument an application. So the next step here is to go to the Go glitch path. And again, there's a README in here. Basically how all the client libraries workshops are constructed is that you basically have an app directory, which is the uninstrumented application. And then you have an app underscore instrumented, which is really the answer to the problem here that you're trying to solve, which is instrumenting your app. If you're not comfortable with Go or you prefer to do a different language, that's perfectly acceptable. So you don't have to do Go. You can go do Python or Node or Java, whatever you're most comfortable with. Hopefully the READMEs are pretty self-explanatory, that even if you don't have a lot of experience with one of these languages, you can get started pretty easily. Typically, I don't like as much of the copy-paste like workshops, but because this is a virtual environment, it's a little bit harder to provide support. Basically, we constructed these workshops in a little bit more of a copy-paste mechanism. You can also just go to the actual documentation. You can go to the GitHub project for any of these repositories, and there's a documentation link for all of them, and you can just follow the docs if you're more comfortable with like how you would get exposure to these client libraries outside of a workshop. But again, if you go into the app directory here, what you'll see is that there's a README file, and this should kind of walk you through all the different steps. As I mentioned, we tried to make this flexible so you don't have to use glitch. So you'll notice that for each of these, we provide some like basic information, how you'd run this locally or how you'd run this in a Docker container, as well as kind of the steps of how you'd run this locally and how that's different than how you'd run it in glitch. So hopefully this provides a little bit of flexibility for you. They all leverage package managers and such, so hopefully this doesn't put a big burden on your system. But if you don't have certain things installed, it's going to take a little bit longer if you're running this locally. One other thing worth noting is that while I do have .env environment files here, glitch actually hides them because the assumption is that they contain secrets. So if you actually read through here, I think I provide what you would actually go ahead and put into your .env file. Basically to make life easier so you don't have to touch the code as much, we've abstracted out all the variables for you using .env. So you can just create a .env file and put the parameters in there, and if you actually walk through the code, you'll see basically where these parameters are being used, for example, like right here. If you don't like this approach, that's fine. You can go ahead and modify the code, get rid of getenv, but we wanted to make this workshop a little bit more approachable, especially given the virtual setup, because it can be harder to follow along otherwise. But basically your goal should be to go ahead and modify these apps and follow the README step-by-step. Again, go ahead, make sure you remix this project, that way you have your own copy of it. You can go ahead and make your changes, walk through step by step. Basically, for each of these, you will go ahead and pull in your dependencies first. Then you typically instantiate some form of a tracer. As I mentioned, you would typically use the OpenTelemetry protocol as your exporting mechanism. We're not doing that here because that doesn't appear to work with glitch at the moment. So we give you an example of it. It's commented out, so you can leverage this locally if you want to. But by default, what you'll see is that Zipkin exporting is what's enabled here for now. So again, flexibility and choice. You can test this in glitch pretty easily, but if you want to test this in your environment and want to know how to get started, hopefully those steps are provided for you as well. Then you go ahead and update your code. So depending on the language that you're using, some of them have like different extensions that will automatically instrument your app. Like for example, Python has a WSGI integration as well as a Flask one. So that's a little bit easier. Typically, you just kind of configure your tracer and your exporter, and then you don't have to go touch your functions. They get instrumented for you automatically. Alternatively, you can go ahead and manually instrument. That may be necessary if you want to add some like interesting bits of information. Like for example, if you want to add your own payload information or like your own spans with their own names, that does require you to add a little bit of custom logic yourself. So we try to provide an example of that for you as well. Again, kind of the basics of how to get started, as well as the next logical step of like, say, for example, adding more metadata to the spans that you're admitting. So once you have this up and running, what you should be able to do is go to the glitch.me website. So you'll have a copy like I did before. You'll go to glitch.me. So for example, mine's over here. And then you go ahead and run the Go app. I have all of my apps done. So it says hello from Go, and then it tells every single path it's connecting. But if you're just starting with the Go one, once you have it working properly, it'll say hello from Go, and then it will say error connecting to Python. That's expected because we're doing the Go workshop right now. Once you do the Python one next, then it will say hello from Python. The idea basically is to chain these together so you can get some exposure to multiple languages and how you get this instrumentation to work end to end. But this is kind of the end state. Once you have everything working, this is kind of the output that you'll see. And the goal is to have it send that trace data to the OpenTelemetry collector instance that you are running. And assuming you have a logging enabled and configured properly, you should see the trace data coming in here as requests are being made. So with that, I'll pause. The goal now is to work on the Go one. Unless you want to work on a different language, that's your choice. By all means, go for it. Would love feedback. If you have questions, if you're stuck, if there seems to be typos or problems, please let us know. We'll be in the Slack channel, definitely trying to help you out. So let's take about 5 minutes right now, let's say 11:25, and try out the Go workshop, and then we will come back and do some of this live again so you can kind of see how to do it should you have any problems. Thanks so much, everyone. All right, going through the Slack messages, just in case you're not following, because there are multiple threads happening here, just worth noting the make file should not be used if you're in Glitch, because basically Glitch is going to automatically start these instances for you, and it's going to consume the ports that you would otherwise need. So if you try to run like make run from the command line of Glitch while the other process is running, you're going to have conflicts. Instead, just go ahead and modify the app, and Glitch will automatically restart it for you. Just like I showed you editing the YAML file of the collector, and you kind of saw the log messages kind of being emitted. The same thing applies for the application itself. Just go ahead and make those modifications to your remix copy in the app directory, and the application should restart, and you should be able to test that the output of the logs are what you would expect. The make file is really there for if you're not using Glitch, if you want to run this locally on your system, or if you want to run this on Docker. The alternative here is you'll see that there's a glitch.json file. That is what's automatically starting the app for you. So you could potentially delete that file if you wanted to, and then you could run it yourself just using like make run in the terminal. That would work in Glitch as well. But the glitch.json files that we provide will automatically restart if you terminate your app. So you'd have to get rid of that file in order to have Glitch stop consuming the ports that you're trying to leverage with the make file. I hope that helps, folks. All right, folks, it's been about 5 minutes. Looks like there's a few questions in the Slack channel that I'm trying to answer for folks. Yes, I would recommend keeping the collector open in one tab and then remixing the Go project in a separate tab. The Glitch instances time out typically after 5 minutes, but you can go ahead and just refresh the page and it will come up pretty quickly. When they go to sleep initially, they're still pretty warm, and they do come up pretty quickly when you need them again. You'll see an error basically in your Go app saying that it can't, maybe you won't actually see. I don't think we enabled the logging one, so apologies. You probably won't see an error that it's not exporting the span correctly because we didn't enable the logging capabilities. That is another part of the workshop that could be added. But you can just go to your collector thing and see if you're receiving the data in, and if not, then you can just restart your collector app and it should be pretty straightforward from there. I'm actually going to test this for you folks locally, just because I think it will show you a little bit of the steps that you can take to make this a little bit easier. So I'm going to show some of that now just to be respectful of time. I know we still have plenty left, but I want to make sure we get an opportunity to test out some of the other languages as well and get you some exposure to them. So what I'm going to do is I have a terminal window here with the, this is the Go app. So Go application. And for now, I'm just going to use the app instrumented one because that one has basically all the steps that we need to get started into the end state. So I can go into that directory. Now, if you've done the README files, then hopefully you've created a .env file locally that can be used to set some of these parameters. So here's what mine looks like for the Go one. So what I've done is configure the server port. 3000 is fine because if I'm running this in Glitch, that's not an issue. I'm going to be running it locally, but because this is the first instance that I'm spinning up, it's okay for it to be on port 3000. And I'm going to say that I then need to configure my next endpoint. So the way that these labs are chained together is that Go calls Python. Again, you can modify this if you want, but there is a Python endpoint. So I'm going to point to the existing python.glitch project. Now, as you may recall, the glitch projects as they stand are the uninstrumented version. That's okay. It can still make that call and go connect to it. It's just that I won't see any trace data for like the Python call, for example. I'll only see it for the Go one. And then I can go ahead and set up my span exporter information. Again, this is in the README file, so you should see examples of this already. I can go ahead and point to my collector. You would update this, so the whatever you remix it, that new name that you got, you go ahead and plug that in before the first dot, and then it always ends in glitch.me. So you just update this to the relevant remix project that you have. You're going to send that data over 443. This is exposed on the internet. We are using Zipkin, so we're going to use the API v2 spans endpoint. But again, if you were running the OpenTelemetry protocol, you would change this as need be. And we are going to use HTTPS because we're sending this over the internet, so why not? So just by setting these parameters in the app instrumented, I should start then to emit local spans for the Go application. And assuming that the Python workshop is up, which it should be right now, I just refreshed it, then you'll actually see that the connection is successful as well. So again, I am doing this locally. So by doing this locally, you'd basically run make run. Again, if you're on glitch, don't do this. But if you're not on a glitch and running it locally, then you can go ahead and fire it up. You can see it's now listening on port 3000 and establishing connections. And then I could, for example, open my web browser to 3000 and refresh here, and you'll see I'm accessing the Python workshop. So I'll accept that traffic, and it looks like the Python workshop's actually down right now. So this is the default behavior that you'll see, which is the Go app is up, but the Python app is down. I'm sure if I refresh this project, it'll come back up, loading, and then hopefully now it will give me a better message, and now it does. So there's an example of where the workshop had gone down, and just by opening up the tab that has the glitch project, you'll see it fired back up really quickly, a matter of seconds, and then the error went away. So the only difference here is now the Go app is actually instrumented. Perhaps the workshop should be updated to say that we added instrumentation and the other ones don't have it, but the call paths are now correct. And then if I go back to my OpenTelemetry collector, you'll see that it actually did go ahead and log trace spans. These are metrics, these are traces. So I did actually receive spans coming in, super cool. So Go is now instrumented in my case. Now, of course, I didn't go through the README and actually add the dependencies and add the tracer and what have you, but hopefully you did. You went through each of the steps in this README file, and your end state should look exactly like the main.go and the app instrumented one, as well as all the updates to the vendor packages that you took on. So yeah, basically we provide the diff files for you. Go ahead and add those modified changes and then go ahead and run it. If you're seeing errors, then you can kind of walk through those. Each of these provide examples for different types of exporting and different types of resources that are leveraged. So hopefully it's not too much overhead, even if you're not that comfortable with Go itself. And if you're just looking to get started, as you can see, pretty easy to just fire up the app.instrumented one, at least locally. If you're going to do this on glitch, then you'd have to make sure that you shut down the other app that the glitch.json is opening. Otherwise, you will have port conflicts. Okay, so that's an example of Go. Now, the general process and steps are the same for every single language, but they're nuances. Like it basically comes down to syntax at this point. So as we walk through Python and Node and Java, you'll see that the steps are similar, but they're language specific as to how you add these instrumentation things. So with that, I'm going to pause for a second. One thing worth noting here is one of the compelling reasons why you'd want to leverage the collector in your environment or a collector of some sort is because otherwise you're putting additional burden onto your applications themselves. So for example, in the case of Go here, if I wanted to send from my Go application directly to a SAS backend, let's say, for example, well, what happens if that SAS backend is unavailable? Do I want to have buffering and retry logic? If I'm sending to a SAS endpoint, I definitely care about encryption. So where am I storing like the API token information and all of that? So typically the goal of the client libraries is to be as lightweight and efficient as possible. The goal is not to put burden on your applications. They're already running pretty intensive workloads probably, and so you don't want to have an impact there. And so you try to offload that responsibility to the agent or the collector, and then you only have to do that once. Like if I add buffer retry logic to the collector, then I add it for one language and I'm all set. Whereas if I add it for Go, that doesn't mean that Python has it. I have to go update Python. And if I want to make a change to how batching works in one client library, I'd probably have to go make it to every single client library. Keeping that in sync is really hard. And even if, like, for example, the OpenTelemetry project ensured that it was in sync, you actually rolling it out through your environment is likely not going to be in sync. So different application teams own different applications. Language-specific things may be harder to roll out in your environment. So ideally, you should instrument and try to minimize the overhead and the amount of changes that are necessary there, and try to offload some of those responsibilities to the collection mechanisms. Okay, so next up, we basically have the Python workshop. So again, another project here. The link should be in the on the web page. Another glitch project. Again, you can remix this. Again, it has the README. Again, there is app and instrumented. So hopefully now it's just going to be following a pattern and learning the nuanced differences between each of these languages themselves. If you go into the app README file, you'll see again that we do provide information for running this locally as well as in Docker. There was one nuance change here, for better or for worse, because this is a Flask application. We're using Flask env in addition to env. Not really a requirement, but that's just how the lab was put together for right now. But everything else is kind of the same here. The Python service is going to listen on port 3000 because that's what glitch exposes, which means the Python service can be hit over the internet on port 443. Super easy. You can configure the environmental variables, and this README has examples of that. We try to link you to the OpenTelemetry project, as well as that project page will have documentation, so you can do it directly from that documentation if you don't want to follow the lab, if you want to follow what the documented steps are, but hopefully it's pretty similar. As I mentioned, some of these projects, in addition to having like their native SDK, which is the primary way of getting the trace or metric data that you care about, also have extensions. So Python is a very good example of that. Pretty much every additional thing in the Python client library is an extension. So here we're, for example, leveraging the WSGI extension. There's also a Flask one. That one's a little bit newer, and it didn't have all of the attributes that the WSGI one does. Which is why we didn't use it for the workshop. We added a note about that. But as the Flask one matures, I'm sure it will have those capabilities in the future. Your choice. You can go play with the Flask one. It's pretty easy to swap out the WSGI with Flask, especially if you're comfortable with Python. But again, flexibility and choice is kind of the goal of these workshops. As you can see here, we're following basically the same exact notion here. Add your dependencies, add your tracer, register your exporter, and then go ahead and instrument your application. How you instrument the application depends on what you're doing. In the case of the integrations can do a lot of the heavy lifting for you automatically. Super cool. But if you want to add in some manual stuff like your own metadata, you can do that within your function calls as well. Your choice. Again, we're trying to walk you through the steps of kind of the happy path, how you get started, and then what's the next logical step. Hey, I want to do something a little bit more advanced. What would that look like? As you continue to get more comfortable with the client libraries, it would be harder to kind of do in a group setting like this, but then you have like asynchronous calls or like batch jobs. How do you instrument them? If you're talking to message buses, like producer consumer type things, what do those look like? We're not covering them in this lab just because it's a lot to cover in the limited amount of time we have, especially in a virtual environment. And as you can see, we're covering the trace path because that's where most people get started. Most environments will have some sort of metricing or log capabilities already probably, whereas they may not have the tracing aspects. Each of these GitHub repos, as I mentioned, do have a pull request up for the metrics capabilities. So the goal is actually to show that off. All the GitHub repositories that you're seeing should be publicly available. Pull requests welcome. Go ahead and enhance them. As I mentioned, there is a pull request for adding basic metrics. So we'll get those merged in afterwards. I didn't want to throw too much at you during the workshops today, but if you're interested in learning more or you want to get down the metrics path as well, those PRs are up and we'll get them merged in here a little bit later on. And then you can update these workshops to test out those steps as well. So like last time, let's take about 5 minutes here and go ahead and try out the Python part. And then for the Python one, I'll probably go through this, the actual manual steps, just so you can get familiarity with how you would actually go through step by step and add the dependencies. I think someone was asking about how to view the README and make changes at the same time. I don't think that there's a split view option in here, but one potential option that you have available is to open up the terminal at the bottom. And then you can have the README up here at the top. You are put into the directory, so you can ls in here, and you can get into the app. This is the uninstrumented app. And then from here, you can just go ahead and modify the files as it sees fit. This might make it a little bit easier for you to get started. The dependency information, again, these commands should work because this won't cause any issues or conflicted ports. And then you can just go ahead and update the app itself. So I think there's VI or something installed. Yeah, perfect. So from here, you can, for example, see the diff, see how we're importing more things, and just go ahead and you can copy and paste if you want and just remove the pluses. You can type this yourself. You can go to the Python doc page and just copy and paste from there. Again, some choices for you. But this, you can go ahead and modify, save your changes, and now your uninstrumented app will become an instrumented app, and then you can diff that against what's in the app instrumented directory to make sure you did it right. And then when you're ready, the app will be running for you automatically. So there is a difference between terminal and logs. If I open up the logs here, you'll see that it's already listening here. So as I make changes, you'll see that make changes down here, you'll see that the logs will automatically update to refresh that application for you. So there's no need again to make run, it'll just happen automatically. Okay, so let's take about 5 minutes, say 11:45. Let's try out the Python one. Go ahead and remix it, and then I will walk you through how to go ahead and instrument Python specifically, and then we'll move on to Node next. Thanks so much. Just a couple updates from the Slack instance so people are aware. So yes, Glitch doesn't ship with Go 1.13. That's actually a requirement for the Go instrumentation. So there is a start.sh script that should be updating to Go 1.13 for you automatically. That does mean that remixing the Go project does take a little bit longer to fire up the first time because it has to install 1.13 before you can get going. Also, it looks like there is an issue with the Go auto instrumentation. You'll see it in the Slack message. Basically, the span sinker needs to be replaced with batcher. There's a threaded conversation about it. We'll get a pull request up to address it in the future, but just a heads up if you're seeing errors using the Go workshop, that's probably why. Otherwise, please keep the feedback up. Like, it seems like people are thinking that this is going a little bit too quickly. We're doing pretty well on time, so I'm more than comfortable taking a little bit longer here before walking through the Python one. I'll poll people in about 8 minutes now just to see where you're at, and you can let me know whether you want to continue working on it a bit or whether you want to kind of see it live on the workshop here. Also worth noting, the Glitch instance, the GitHub instances, they're going to remain online. So you can totally do this workshop even after today, even after this week. They're going to be available. There are no plans to take them down other than Glitch will power them off after 5 minutes. So they might take a little bit of time to boot up. Submit your pull requests even after today, more than welcome, right? So no worries if you can't get through all the workshops. All right, folks, it looks like a few people are hitting a 404. That's what I was experiencing before. You might recall when I remixed the collector, so you're not able to send the traces. Let me just share my screen. All right, hey folks, it sounds like a few people are having issues with the 404 on the remix collector. So I just want to walk through that real quick. I was seeing the exact same thing when I remixed initially, if you remember. So here's what I did to make it work. I just went to share and got the actual live app code. That's what I'm using to actually test out. And then I went and made a configuration change, wait for it to break. So it now says that I have an invalid config. And then I put that back in, wait for it to reconfigure again and come back online. And then I just tested a second time and the 404 error went away. So if you're seeing a 404, it just might mean that Glitch had an issue where it didn't reconfigure your app correctly and didn't expose it properly. So just by making a quick config change, I'm able to get at least mine back online. Hopefully that will help you as well. So try it out. If you're still having issues, please post in Slack. We'll take a look and try to help you. Otherwise, we'll get started here in about 2 to 3 minutes on the Python workshop. All right, folks, let's kick it back off again. I'll let people continue working in the background. I wanted to show how to run this locally first because a few people have been asking. So I just want to walk you through the steps. And again, feedback welcome right up this way to make the README a little bit clearer. So here I have locally downloaded the OTel workshop collector. I can actually run this through the makefile. So if you look in the makefile, you'll see it has targets. The only one that we care about is the run one. As we mentioned, there is a typo here. We're going to get that fixed and get a pull request up. In my case, I'm in a Darwin environment, so I would have to go ahead and add Darwin in order for this to work. I think I have a copy of Darwin. I do here. Into this directory. So you will need to make sure you have the right one for your environment, and then you just go ahead and specify the config file that you want to run with it. So the standard collector config, this has metrics only. The config complete has tracing as well, You might want to make modifications if you're running this locally though. So let's just run it with metrics. Again, the output should look very similar to what you're seeing in Glitch. You can see that everything is working properly. We can also go take a look at the complete one. In the case of the complete one, you may recall that we exposed Zipkin on port 3000. Given that we're running this locally, that's no longer a requirement. That was just for Glitch specifically. So we can use port, for example, 9411, the standard Zipkin port, if we want to make this work. In the complete example, there are examples for Open Census, OTLP, there's even Jaeger in here. So you can mix and mingle however you see fit. Just make sure that you've enabled the appropriate ones down here in the tracing section. So here in my case, for example, I just enabled Zipkin on its standard port, 9411, and then I can go ahead and again run the collector, this time with the complete YAML file. And I should see, based on the output here, that it's gone ahead and added the tracing capabilities. And I can see that it added a whole bunch of receivers, Open Census, Zipkin, OTLP, so I can confirm that they're running. These are all info messages, so there's no errors here. Everything appears to be happy and healthy. And then if you're interested, again, the Netflix example I really like. It's a pretty simple way to just test locally that you're able to send traffic. So I can send this time to localhost a 9411 because I'm running this on my local computer. And I'll send this to V2 spans. Go, the Netflix thing, and then I can come back over here and I should see, yep, I received trace data. So that confirms that locally I am now running the collector. Now I can keep that running in one tab, and then I can go over to whatever other app I care about. So for example, if I start with Go, because we had done that previously, I'm in the app instrumented thing here. Again, there is the .emd file that you should have created, and you can point this however you see fit. So for example, I can use server port 3000 because nothing is consuming that locally right now, but maybe I want to run Python locally, not use Glitch. So what I'll do is I'll just get rid of the Glitch endpoint and I'll add a localhost one. I need to pick a unique port though, so I'll just use 3001. We'll string these together sequentially. And then I would have to tell it where to send the data. So instead of sending, for example, to the collector on Glitch, maybe I want to send this locally. And instead of to port 443, which is Glitch, I want to send it to Zipkin on port 9411. And again, because I'm local, it's HTTP and not HTTPS. So I just basically modify my env file with the parameters of my local environment. And so now when I run this Go application, it's going to attempt to connect to Python on 3001, which isn't running yet. That's okay. And it's going to attempt to connect to a locally running collector. I'm running that in a different tab over here, so that's great. I need to tell it what port and what path and what protocol. That's done, and then I can just go ahead and run make run, and my Go application should start up. You make it pop up about network connections. I'm going to allow it in my case. So now I have Go running on port 3000. So let's go ahead and open up my web browser now, and let's go to Go 3000 and refresh. And what I should see is hello from Go. But error fetching from Python because my locally running Python instance is not up yet. That's okay. Well, I should also see that there is some amount of trace data reaching the collector because the Go app is instrumented now and it's running. So I can actually see that there is trace data coming through. So that confirms that I now have Go sending trace data. If I want to actually see that trace data, the only other thing I might consider doing is changing the log level as we saw before. So if I go to logging here and set the log level to debug and start this collector back up again, and let's just rerun my Go app. Rerun my Go app. I might need to wait. There we go. Sorry, my screen didn't terminate. Scroll down. So I still see the logging 5 spans, and then I can actually see what those spans are, and I can see the data that I'm sending in. As you remember, I set like an attributes processor on the collector, setting an environment tag. I can now see that environment tag in the payload. I can see any other metadata that was associated with this, like the kind of the span, the trace ID, parent ID, type information. All that information is being sent. So any instrumentation that I've added, I should be able to see pretty quickly and easily. I can also see pretty quickly and easily that the Go application cannot talk to Python. Connection refused right now. So this is very helpful to at least look locally. Of course, if you're running this locally, it's very easy to spin up like a Jaeger all-in-one or a Zipkin all-in-one and then configure an exporter to a local Jaeger or Zipkin. That's totally fine. You can totally do that. And then you can actually see this end-to-end without using the logging exporter of the collector. That's definitely not a requirement here. So now we have the Go app instrumented. I'm going to walk through the Python one, but again, just to kind of show this locally so people are aware, I'm in the app instrumented folder here. So this has already been instrumented for me. I can open up the env file and I can just give it some information about where endpoints are. So if I assume that Python's going to be on 3001, node, which is the next service I'm going to call, should probably be on 3002. Again, probably want a local collector, so I can see this end to end. I'm going to need the appropriate port. I'm going to need the appropriate protocol, so I can save that. As you might recall, we're using Flask env to set the port, so I need to make sure that's set to 3001. It defaults to 3000 because again, the default behavior is to run this in glitch on different instances. But if I'm running that locally, that would be a port conflict, so I need to go ahead and update that port. And then my application should be all set here. So now I can just go ahead and run it. You can see it's listening on localhost 3001 now. That's great. So let's go ahead and just test 3001 and see if that's working. Hello from Python. Great. Cannot connect to node. We didn't spin up nodes. That's expected. And I should see trace information here at the bottom. Let's just run that one more time so you can actually see it. And we should have trace information coming through here. Assuming I ran the right application, which I might not have, but I thought I did. Make run in instrumented app. Yeah, this should have exported. There we go. There's this delay in the console stream. So here's the export for the next one. And very similarly, we should see all the metadata associated with this and any connection to any downstream services. So that all shows up, which is great. And then if I go back to my Go app, so I'm now running the collector, the Go app, and the Python app in 3 different terminal windows. Now I should actually see hello from Python when I call from Go. I do, great. So hello from Go, hello from Python, can't connect to node. So again, this is just show you how to run it locally. It's just basically based on the environmental variables that you're setting. You just need to make sure you don't have a port conflict here. But otherwise, nothing prevents you from firing this whole thing up locally with the right ports in the env setting. Okay, so hopefully that was helpful. I'm going to shut this stuff down real quick so I don't consume a bunch of resources. Great. And then I said we'd walk through a little bit one of the workshops. So let's go ahead and take a look at Python here. Great. And let's just open this up in 2 windows so we can do this live. Okay. So the app one is the uninstrumented one, as we already mentioned. The README basically tells me the steps of what I need to do. I need to set an env file, so I've already gone ahead and done that. Here I'm pointing up to the glitch instance, but again, I could configure this to a locally running instance, your choice on how you want to do it. Either way works. There's also a Flask env. Defaults to 3000. I just shut everything down in the other windows, so 3000 is no longer consumed, so that shouldn't be an issue. Great. And then basically we need to go through an instrumenter application. So first up is we need to go ahead and install all the dependencies. I mean, this is just a copy paste. I can just take this and go run it in my virtual environment, and it will go ahead and pull those dependencies for me. Because the virtual environment doesn't impact my system-wide Python pip installation, which is great. So now I have the dependencies I need for the OpenTelemetry components. Next up is to just go ahead and instrument my app. So if I open up my app itself, it's pretty bare bones to start, pretty simple web Flask application, just calls a downstream service. We're gonna have to go ahead and add in all the associated dependencies to make this work. So let's do that. And let's kind of walk through these real quick. So clearly, if we're using the tracing capabilities, we need to import that from OpenTelemetry. There are also metric capabilities. We're not showing that here now. Again, there is a PR, pretty simple for you to go take a look at how you can get started with the metric capabilities. You could leverage the OTel collector OTLP exporter capabilities. Again, for glitch, we're using the Zipkin one. Any exporter that's supported, you can go ahead and configure. There's no real hard dependency here, whatever you see fit. The best practice would be eventually switching to the OTLP version, because you should send to the agent collector, and the agent collector can actually transform that and send to any other backend. So just because you send OpenTelemetry protocol from the instrumentation to, say, the collector running as an agent, the agent can convert that into Zipkin or Jaeger or whatever, right? SignalFX, Stackdriver, Honeycomb, Laceb, doesn't matter, right? So there's lots of flexibility there. Again, the goal here is a vendor agnostic solution, supporting at least receiving all the open source inputs and then sending to either open source or commercial backends is the net goal here. As I mentioned, there's a variety of different extensions. Python's a pretty good example of this. So we're getting like the HTTP request extension. We're using WSGI. There's also Flask. We just didn't use that because of attributes. You need to get the tracer information. So the tracer is how you get like the trace ID information, and you can enhance it and add your own spans yourself. And here we're actually leveraging the batch span processor. So I mentioned that you typically want to offload as much of this from the instrumentation as possible. Batch might be the only exception to this. So enable batching in the instrumentation is a positive thing, because it means like less connections and less load on the system having to emit every single span that's being generated real time. So this really helps from an efficiency standpoint. All the client libraries should have some form of batch, but that's probably the only one that you need in terms of processing. Everything else can be handed off to the locally running agent instead. So here's our Flask application. We've now gone ahead and added in all the dependencies that we need. Again, we talk about why it's using Zipkin, so I've already reiterated that multiple times. Next up, we have to go ahead and enable configure our tracer and our exporter. So again, just for simplicity here, I'm just going to copy and paste this to make it a little bit quicker. So two things. So first, we have the exporter. Here's the OpenTelemetry exporter. Again, not using that because Glitch doesn't allow it, but if you're running this locally, nothing prevents you from trying it out, so pretty easy to uncomment it and try it. We also provided the Zipkin exporter for you here. Basically, what you need to do is configure two things. One is the service name. What do you want the service name to show up as? Here, we're hard coding it to PyService. I mean, if you're in Kubernetes, you can pull this in. Like, there's a variety of ways of setting the service name, but you usually do this within the instrumentation itself. And the second is, where is the endpoint that you're trying to send to, and what parameters do you need for that endpoint? And sometimes things are not consistent. So like the OTLP one uses endpoint, whereas Zipkin uses hostname. Just check the docs and just make sure you're using the right one. But here you can see we're setting the host, which is the destination we want to go to, the port of the destination, what that endpoint is. This is basically the path. Maybe path would have been a better name, and then the protocol, whether it's HTTP or HTTPS. So pretty straightforward. You configure this once. So typically how this is done is I wouldn't do this in every single one of my Python files, right? I abstract this in a class and I go import it. So I define my exporter once, and now I can go ahead and go leverage it. There's no need to define it multiple times. Next up, we have to go ahead and get our tracer information. So here we're just going to pick up a new tracer. And in this case, we're going to say for that tracer, we're going to create a provider. We're going to have that provider batch the data and then send it to the destination. So here you can see it leveraging the batch span processor and see it calling the span exporter, which we defined above it. Again, one-time operation. Now I can go ahead and I can use this tracer wherever I see fit, or I can leverage the integrations and some of the more automatic spans that get generated for me. So that's the next step. Now, the thing worth noting here is you can see that we're using .env, a pretty common way to pass in environmental variables, pretty language agnostic. There's like a fork of this for pretty much every language today. You can use whatever you're comfortable with. It doesn't have to be .env, but here we are just importing environmental variables and not setting them or hard coding them in the code. The goal here was just to make the workshop a little bit easier, so you're not having to poke around everywhere in the code to go figure out where to update ports and such. So again, you set this in your .env file and it will just work for you automatically. Then finally, we have our instrumenting of Flask app itself. So basically what we want to do is we want to enable HTTP request, which is one of the extensions that was provided to us automatically in OpenTelemetry. It's pretty great. So now we get those spans for free. And then finally, we want to enable the middleware to get the Flask-specific information coming in. Oops, right here. So basically, those are the only changes that I made. There is no need to make actual code changes within your functions themselves, given that we're leveraging these extensions here. However, you are free to do so. So for example, if you want to add your own span, if you want to give it your own name, if you want to add your own metadata, that's entirely possible. So basically what we're going to do is we're going to, in the hello section, we're going to add that in, and we're going to replace our existing stuff with this. So now we're basically saying, hey, I have a tracer. That's what we defined earlier, right? I am going to start a current span, and I'm going to call that span fetch from node. That's what I want to call it. Then I'm going to go ahead and execute my function fetch from node and grab that response, and then say hello from Python with that response. So this is just a way of manually adding more instrumentation for something that I think is useful. Another reason why you might do this is because you want to add explicit metadata that like an extension doesn't provide for you automatically. So this is like the next step. You wouldn't typically do this by default. Just by enabling the dependencies, the exporter, the tracer, and the integrations, you get some pretty rich information that gives you your service-to-service communication information for free, basically. It handles all your context propagation for you for free. I guess quick note on that. All the OpenTelemetry libraries are leveraging W3C trace context for the context propagation format. Most of them have B3, not all of them at the moment, but the goal will probably be to add B3 to all of them. So in case you're using B3 in your environment, you can. But this basically abstracts away the notion of context propagation for you pretty easily, unless you have to go set it yourself. So now that I've gone ahead and I've made those changes, I can write those to the file here and make sure everything is happy. I can make sure that my .env again here is pointing to the right place. Maybe, for example, I want to run this. Well, that's fine. I'll go to the node instance. So now I should just be able to run make run, and my application should start up, assuming that I don't have any errors, which it seems like I do. I didn't add the Zipkin dependency, so that might be a typo in the thing here. OpenTelemetry Zipkin. Okay, let's try it again. String port and
hi Steve, always here. Can you hear me?
Yep, can hear you.
Hey, we need to install a fork version of Zipkin because the main version has a bug. I updated the README on GitHub and I also shared on Slack. So if you can just grab that one, it looks like a long URL from GitHub.
Got it. Okay, cool. Yeah, I'll pull that up in 1 second. Thanks always. Okay, so yeah, I'll pull that in. As you can see, I had a typo in my config. Again, we'll make sure the README is updated for this. So this will probably not work based on what always just said, but hopefully at least the app is up. Hello, hello, hello. Great. So again, we started the initial path. You can see that there's a bug in the Zipkin. So it looks like, as always said, he has pulled in a new version. So let's do that. Git pull upstream master, and then get stash pop. Cool, make run. Okay, let's try that. See if we have better luck.
Steve, I only updated the README, so you'll need to redo step number 1.
Got it. Thank you. The changes here. Oops.
Hey, sorry, you need to update the requirements file, requirements.txt.
With what, this?
Yeah, with everything in there, and then just run make install, and it'll install all the dependencies.
I see. Hey, oh, still unhappy. None. All right, well, we're getting close on time. I'll figure out why this is wrong. It looks like my environmental variable did not get pulled in. This might just be, this didn't spell .in. Okay, so I'll take a look as to why. But if you have any issues, let us know in the Slack channel. Hopefully that would have instrumented the app here for us and brought it up. And then you should see it connecting in through the local host, or if you're running on Glitch, it should appear in Glitch as well. Everything I did locally here, you can do in Glitch. Again, you'd have the terminal window up on the bottom, you have the README file up on top, and you can kind of follow along, import the necessary things, and the service should come up. So we're clearly kind of close on time now. I do want to be mindful of that. There are other labs here for Node and for Java. They follow very similar steps. There shouldn't be a lot of surprises here. The only thing, and I called this out earlier, but just to remind you, the Java one does not offer a Zipkin exporter today. So the Java one will just log locally to the Java app itself. Again, if you're running this locally, you could leverage like the OTLP exporter. But if you're using Glitch, unfortunately, because we can only export one port at a time, this will only log locally until Zipkin is added or until we can move to OTLP end-to-end for all of the labs. But anyways, would love to get your feedback on these. Definitely try them out. The Slack channel, I'm assuming, is sticking around. That's a question for the organizers, but I suspect that it would. These Glitch and GitHub projects are definitely sticking around. So no rush here. Feel free to submit PRs, comments, issues, whatever. We're happy to take a look at them. Definitely want you to be successful with it and kind of try it out and see what it looks like. Other than that, just keep in mind that these projects do shut down after 5 minutes. If you just open the tab back up again, usually they'll refresh pretty quickly if they are not online at the moment. It's pretty easy to test these things locally or through their glitch URLs. So feel free to test that as well. Other than that, hopefully this gives you some good exposures to multiple different languages. As you can see, there are a variety of steps. One thing that we did not have an opportunity to show that I'm hoping to add as a future lab is the auto instrumentation. So what you might have noticed is, hey, getting started with the collector, pretty easy. Update a YAML file, it kind of just works. Instrumentation, language specific. I have to add dependencies and a tracer and an exporter. A little bit more work potentially, like I have to go read some documentation. Auto instrumentation tries to offload that burden. So the idea here is that you hook into your existing application. It's usually a config change that you make to your application before it starts up. And then the app gets instrumentation for basically for free, usually service-to-service communication for free. And you can mix automatic instrumentation with manual instrumentation. So maybe you leverage the automatic, but then there's another function you want to instrument manually. You can go ahead and pick up the tracer from the automatic instrumentation and enhance it with additional span data. So that would be a good future lab exercise. We did not have enough time to kind of show that off today, but that's kind of the future. The goal is to offer automatic instrumentation for all the popular languages that OpenTelemetry is supporting, again, to make this easier. Because maybe you're on the platform team and not a developer, and so like you don't have access to the code, or maybe you know Java but you don't know Node or Python, and so the auto instrumentation can kind of provide the initial hooks for you pretty easily. So again, the goal is kind of flexibility and ease of use here. With that, I'll be available in the Slack channel probably for the next 10 to 15 minutes, probably until about 12:45. So definitely continue to put your comments in there. I hope this was helpful. I understand it's a little bit hard to do it in a remote session. I definitely appreciate all the feedback I received so far. Hopefully it's not going to be too, oops, what happened here? Sorry that it was a little bit too fast. The goal was to kind of show you different aspects and hopefully give you enough time. But please do try this out later on today, later on this week, and let us know your thoughts on ways to improve this and to make it better. Also, we hope that you will contribute and join the OpenTelemetry project. All the SIGs are open. Feel free to drop into them. There are lots of good GitHub issues depending on where your interests are. They're usually labeled pretty well, like good first issue or help wanted. So please get involved with the community here. There are lots of people involved, end users, like third parties, cloud providers, vendors. So it's a very rich ecosystem. It's maturing very, very quickly, and it's only going to be successful with your help. So thanks so much for joining. Really appreciate it. I'll stay on for questions in the Slack channel, and otherwise, I hope you enjoy the rest of the conference today.